Welcome to The Explainer. Grab your hard hats because today we're jumping straight into the trenches as senior systems engineers to deconstruct an absolutely fascinating digital blueprint. We are going to review the highly constrained, brilliantly ingenious architecture of a localized edge computing cluster known as Exocore 2026. What really makes this so compelling is exactly how it achieves modern automation and AI integration, all while using heavily restricted everyday hardware. It's a masterclass in making do with what you have. Here's our roadmap for the system briefing. We're moving top-down today, starting with the core system objective, then breaking down the hardware node specifications, tracing the network data flow, analyzing the application stack, and finally, digging into the production output methodologies. Let's get right into it.
Section 1. The Exocore 2026 System Objective.
As engineers, we can't truly understand the mechanics of a system without first understanding the why behind it. So let's look at this quote straight from the creator's system blueprint. Old computing degree from 1997, never gained employment and outdated, now want to update my learning with a core focus on leveraging AI freemium/free tools to generate 3 passive income streams. This raw, honest motivation completely establishes the human element driving this engineering. It highlights a massive, necessary pivot from an outdated 1997 computing paradigm, way before the cloud and modern AI, to an agile, modern approach that leverages free AI to build a self-sustaining financial machine.
Taking a 10,000-foot view of this topology, we see a really brilliant decentralized architecture. Instead of relying on a massive, expensive centralized server in the cloud, this entire system is built across 3 distinct everyday hardware devices. This is edge computing in its purest, most localized form. It's designed explicitly to overcome extreme hardware limitations by breaking heavy tasks apart and spreading the load.
Section 2. Hardware Node Specifications. Now, hardware limitations usually stop a project in its tracks, right? Not here. Here, they are a forcing function for incredibly efficient system design. 4. That's it. Just 4 gigabytes of RAM on the primary development node, which is a Dell Inspiron 13. For a little context, as a systems engineer today, trying to run local AI models, development environments, and automation scripts on just 4 gigs of memory is insanely restrictive. It's a massive bottleneck. And that severe limitation is exactly why all the heavy processing absolutely has to be modularized and offloaded.
So, how do we bypass a 4 gigabyte bottleneck? We distribute microservices across 3 separate physical nodes. Here's the exact role allocation. The Dell Inspiron 13 handles the development, the research, and acts as a Telegram listener. Then the middle tier is a TCL 50T smartphone, which acts as a node web server and runs Telegram apps. Finally, all the heavy lifting is pushed over to a Samsung A05. That device is totally dedicated to Qwen AI processing and running active application testing. It is a textbook, perfect example of load balancing across available, consumer-grade hardware.
Section 3. Network Data Flow Architecture. Now that we know the hardware, let's actually trace the exact communication protocols and the data journey between these distinct nodes. First up, we really need to understand the role of the TCL 50T. This device operates as a node web server. In this specific architecture, it acts as our absolutely critical middleware. It receives JavaScript code deployments directly from the primary Dell node's VS Code environment. Basically, it's acting like a traffic cop, routing commands between the primary interface and the processing nodes. Once that node web server receives a command, it needs a standardized way to talk to the AI unit, right? So tasks and requests are packaged up as JSON objects. For those who might need a refresher, JavaScript object notation is a lightweight data interchange format. It's super standard. By packaging tasks into these JSON objects, the TCL 50T can efficiently push requests asynchronously via Telegram straight to the Samsung AI processor.
And this sequence brilliantly illustrates the primary automation loop of Exocore 2026. Step 1. A JavaScript deployment is triggered right from VS Code on the Dell. Step 2. It hits the node web server hosted on the TCL 50T. Step 3. It's converted into a JSON object and passed via Telegram over to Qwen AI on the Samsung A05 for the actual processing. And finally, Step 4. The results and responses are sent back as notifications to the Telegram listener sitting back on the Dell. It is a completely closed-loop, automated microservice architecture running entirely on standard consumer tech. Incredible, right?
But wait, alongside that primary asynchronous AI loop, there's actually a secondary, direct physical connection at play here, using ADB, or the Android Debug Bridge. As a systems engineer, you'd use ADB as a command line tool to send instructions directly to an Android system level straight from a connected computer.
In this specific topology, the Dell Inspiron uses Android Studio to push data directly to the running app on the Samsung A05 over this ADB bridge. So think of it this way. While the TCL50T handles all the asynchronous AI automation via Telegram, the Dell maintains a direct hardline connection to the Samsung for real-time application testing and rapid deployment. It's covering all the bases.
Section 4. The Application Stack.
A crucial part of this whole system is understanding the specific freemium tools that are actually turning the gears inside this machine. Looking at the primary node, the Dell is running a surprisingly robust development stack, especially considering it only has 4 gigs of RAM. It's utilizing essential dev tools like Visual Studio Code, Android Studio, Node.js, and GitHub to orchestrate the entire system. Plus, it features content creation tools like YouTube Studio and OBS Studio, which gives us a pretty big hint at the end product goals of the overall system.
Now, to maintain that strict zero-cost overhead the creator was aiming for, the system completely leans on an impressive suite of free and freemium AI applications. We're seeing powerhouses like Perplexity, Gemini, ChatGPT, and Copilot. But as systems engineers, the thing that truly stands out here is Quinn AI on Termux. Termux is a terminal emulator that gives you a Linux environment right on an Android device. Running a local AI model like Quinn directly on the Samsung phone's hardware via Termux, that is exactly how this system achieves local edge AI processing without racking up any cloud compute costs. It's a brilliant workaround.
Section 5. Production Output Methodologies.
So, at the end of the day, what is all this infrastructure actually producing? Let's look at the output metrics and the governing philosophy. The blueprint notes a very specific, overarching engineering principle. The process becomes the product methodology. This essentially dictates that the very act of building, testing, and refining the Exocore 2026 system is itself the core value driver. All the trial and error, the deep documentation, the architectural design tweaks, that entire process is what actually generates the content and the final products.
Let's see how this builds into the final output. The architecture successfully pivots the creator far away from the old methodology, which was seeking traditional employment with an outdated degree. Instead, this new methodology funnels the automated system's output into 3 distinct passive income streams: ebooks, Android apps, and YouTube videos. The system itself is literally the factory producing these digital assets.
And of course, no closed system survives for long without fresh data inputs. The creator constantly updates Exocore's capabilities by sourcing brand new tools and inspiration from directories like there'sasanaiforthat.com and marina.ai. These act as the external knowledge feeds, ensuring the system's software stack remains absolutely cutting edge despite being constrained by older hardware.
As we wrap up this explainer, I really want to leave you with a systems engineering thought experiment based on everything we've just unpacked today. If an automated multi-node product pipeline can be successfully architected using just an old laptop with 4 GB of RAM, 2 everyday smartphones, and a suite of free AI tools, what does the future hold for traditional software engineering? Hyper-constrained, decentralized edge AI setups like Exocore 2026 prove, without a doubt, that the barrier to entry for complex system automation is lower right now than it has ever been. It's a fascinating, massive shift in how we build and deploy technology. Keep experimenting out there and stay curious.